Hello everybody and welcome to example 2 on page 39. Let's take a minute just to read this question together here. So a rectangular city having a length of 5 kilometers and a width of 3 kilometers borders along the ocean as shown in the diagram to the right. The population density of the town at a distance of x kilometers from the ocean is given by the function sigma of x equals 500 minus 30x squared people per square kilometer. Okay, so before we dive into this, notice that the function that they're giving us up here is just telling us that the density of our city depends on how far we are away from the ocean. That's kind of the basic observation that we have here. Okay, so let's look at the questions then that they're asking us, starting with part A here. So they're asking us, where is the population density of the city the greatest? Okay, well, that means we need to look at our density function and ask ourselves, where would we get the biggest output value for that function? Okay, if you think about that for a minute, if you substitute 0 in for x, that's going to give you the biggest number possible out. Okay, remember x represents a distance, so it can only have positive numbers. And so my answer to part A would be, we're going to get the greatest population density at x equals 0. Okay, now I'm going to ask just kind of a follow-up question to that. What's special about x equals 0? Where are we in the picture if x is equal to 0? Well, x measures distance away from the ocean, so if x is equal to 0, we are right on the coastline. Okay, and so that's really what's significant about this. Okay, and that makes some sense because more likely that people are going to want to live next to the ocean than farther away from it. So we'd expect to get more population density there. Okay. So with that in mind, part B would like us to find the population of the city. Okay, now how would we do that? Okay, well, we're going to use the same principle that we did in the previous problem, taking population density and multiplying it by something to turn it into a population. Okay, now one comment before we do this. This would be an easier problem if I told you, if I had given you one number for the entire city and said, for example, the population density everywhere in the city is 100 people per square mile. You could have said, oh, okay, well, if we have 100 people per square mile, I'll just calculate the area of the city, which would be 5 times 3 is 15 square kilometers, and multiply that by 100 people per square kilometer, and you would get the population that way. The trouble is we can't do that because the population density changes depending on where we're at. Okay, so we're going to use the same kind of a slicing strategy and say, could we slice our city up in a way so that along one slice, the population density doesn't change very much? Okay, so the key is we want to slice it in such a way that the density stays approximately constant on the slice. Okay, if you think about that, the way that we want to do that is so that a slice of our city stays about the same distance away from the coast. Okay, so we might choose to slice like this. I'm going to call this the strip. Okay, just a strip of population. Okay, and what makes that a good choice, that way of slicing, is the fact that the distance from the coast is approximately constant. It's about x everywhere in that strip. Okay, and so what we want to think about first then is, how would we estimate the population just in that strip that we drew? Okay, well, we can approximate it by first taking the population density, which we know is given by this function up here, 500 minus 30x squared. Okay, and I'm going to remind you of what the units of that are. We're talking about people per square kilometer. And my question to you is, what units would we need to multiply those people per square kilometer by in order to get a population? Okay, because we want to get people. If you think about it, we need to multiply by square kilometers so that those units cancel and we just get population in people. Okay, so what kind of a quantity is measured in square kilometers? That's really area. Okay, we're talking about area here. Okay, so how would you find the area of this strip, okay, that we drew in up here? Okay, well, that's a rectangular strip, so we just need to take its height times its width, basically. How high is that strip? What's its length vertically? Well, you can see that that's going to be the 5 kilometers, okay, on one side of our city, and its width, we'll call it dx because it's a very thin strip. We want it to be thin so that the population density stays approximately constant. Okay, so in a nutshell then, this expression, 500 minus 30x squared times 5dx, that's approximately the population of the city just in the strip that we talked about. Okay, so how do we get the total population for the entire city then? Well, we need to add up the population in all of those strips left to right, and to add up, we generally integrate. Okay, so we're going to take 500 minus 30x squared and multiply by 5dx, and then the question is, what would our limits of integration be here? Okay, well, ask yourself, what is the range of x values as we go from one side of our city to the other? We've got x equals 0 over here on the right along the coast, and then what is x equal to here, the left? How far away from the coast are we? Well, we can see that that's going to be 3 from our picture. Okay, so our range of x values is 0 to 3. That's what our limits of integration have to be. Okay, and if we can do that integral, we have found the population of our city. Okay, so we might start by taking this 5 and just distributing it through. So 5 times 500 is going to be 2,500. Minus 5 times 30, x squared is 150x squared. Okay, we need an antiderivative now, so integrate 2,500, we're going to get 2,500x. And then 150, let's see, that's going to be 150 x squared. Antiderivative is x cubed over 3. Okay, we can do a little simplifying. So 150 over 3 is 50. I'm going to do that simplification before we plug in our limits. Okay, and we're ready to plug in our limits, so let's see. If x is 3, we're going to get 2,500 times 3 minus 50 times 3 cubed. And if you plug in your lower limits, you're just going to get 0 everywhere. So if you just take out your calculator, maybe you can do that in your head. Either way is okay. You're going to get an answer of 6150. And what should the units on the answer be that we got there? Okay, well, we kind of already figured out our units up here. Noticing that the kilometer squared canceled, we're going to get units of people, okay, which makes sense because we're measuring a population here. Okay, so we have figured out that there are 6,150 people in this city.